Let's go over this question. Question number 23. Question 23 says, according to equation 1, the concentration of the polymer with respect to hydrogen phosphate is what? So if we go to equation 1, we have two players here. We actually have the concentration of the polymer, right, which is right over here. And we also have the other player here, which is the hydrogen phosphate, right? And the thing you need to know about this is that every time we add a phosphate group to this polymer, the concentration of the polymer doesn't really change, right? The length of the polymer increases, but you still have one polymer. On the other hand, if you look at the hydrogen phosphate, every time you add one phosphate group to this polymer over here on the left in purple, you also add an additional hydrogen phosphate. So the hydrogen phosphate here actually increases, right? So what do I mean by that? If we go right over here, let's do a few examples. If you have a hydrogen phosphate, right, let's go back over here. You have one polymer, CP1 of length 1, right? Notice you still have one polymer, which is in green, and the polymer is of length 1, which is in purple. Now notice once you add one phosphate group to a polymer, you actually have one phosphate group. You release one hydrogen phosphate. So what is the ratio between the polymer and the hydrogen phosphate? That's a 1-to-1 ratio, right? That's the concentration. It's even right now. Let's look at the second example right over here. I have I have two hydrogen phosphates here, right? That's a result of having a polymer of length 2, but you still have one polymer, right, of length 2. The polymer concentration has not changed. But remember, every time you add a phosphate group, one goes directly to the hydrogen phosphate. So now notice the hydrogen phosphate is, the concentration has doubled. So let's look at this ratio again. Polymer of length 2, you still have one polymer, but you have two hydrogen phosphates. Let's go over here again. I have a polymer, it's still one polymer here, right? It's of length 3. Remember, the concentration of the polymer does not change. But we have 3 hydrogen phosphates now, right? So again, here's the ratio of the polymer, which is in green, which is 1, to the hydrogen phosphate, which is 3. So it's a 1-to-3 ratio. Now the question actually asks, what is the concentration of the polymer with respect to the hydrogen phosphate? In other words, how are we going to relate these two concentrations, right? Well, we're just going to multiply it by a factor of 1 over n, right? And what is n here, right? Let's actually do it like this. We're going to multiply everything by a factor of 1 over n, right? In this case, n here is 1, which is in purple. So I'm going to multiply it by 1 over 1, and that equals 1, right? Let's go over here. Polymer of length 2. Let's go in the second row. What is n over here? That's 1 over 2. So I'm going to do over length 2, and that equals to 2, right? I hope you're starting to see the trend over here. 1 over 3, if I multiply of length 3, right? So how do we actually relate the ratio of the polymer to the hydrogen phosphate? Well, that would be choice C.